Hey guys, just want to show you what I've been working on. This is a gate motor. I had this for a while and I've decided to use it for a mixing blade. So I got here I've drilled a hole through this shaft here and the shaft of the motor, 6 mils, to put this bolt through to lock it. Then on here we got a propeller. This is a very nice propeller. My dad just had this lying around and it's all made out of stainless steel, so it should be resistant to anything I've put in there. It's got two Allen key lock screws here to lock this on the shaft. If I loosen this, the propeller just falls off. And yeah, and I'll be using this to mix bleach and acetone to make chloroform on a large scale. But the whole reason is not to make a lot of chloroform. It's just the whole fun process of building a big reaction chamber that's going to have cooling coil and the spinning blade and a frame for my dropping funnel. And alright, so I got a lid for the bucket. I've drilled 2 holes from here and here for the coil, so there's going to be a rubber pipe attaching the coil pipe and this pipe because the pipes are the exact same size, and this will allow me to actually unclip the coil if I want to and clip it back on. And there's also going to be, it's bent on the side to lock onto the bucket, and this is for a pipe that's going to go here with the circle for the dropping funnel. The motor will be sitting perpendicular to this plate, so we're just going to drill a hole, unattach the blade, and then push it through. We don't have to drill a hole the size of the blade's radius. Hey guys, just an update on what I've done so far. So I'm nearly finished with this whole project. So right here, this is the lid of this bucket here. It can hold 20 liters of bleach, and this here gate motor will turn this blade here, goes through here, and I got a propeller. I got the coil here. I've already tested for leaks during here. This one had to be tightened really much because there was a leak over here. This course will go back into the bucket where it will pump ice cold water through the coils, cooling the bleach. Now thankfully I got lucky that this coil was stainless and not aluminum, because I would have gotten eaten away very quickly. Now I have a thread bar over here with this adjustable ring. And this is where my dropping funnel or separatory funnel is going to be to drip the acetone through this hole over there. That will also act as a gas release, but it's not like perfectly sealed around the lid, so the gas can just migrate through there if there's any pressure buildup, which I highly doubt. Okay, so this also was wobbling. It wasn't centered, so we had to take a center punch and a hammer, and inside, as you can see there, you just knock a bunch of on this shaft here, a bunch of points with the center punch, which actually makes this a lot firmer. So that's a little neat trick. You're not meant to do that because it ruins the shaft, but it's not like a professional machine because it's just a gate motor and I'm not going to really use it for anything else. So the next step is going to be setting the separatory funnel, the drip rate. I'm going to be using methanol for that, so I don't waste acetone, and because the viscosity is very different to water, so I can't really use water. So yeah, so then once I get the drip rate right, I'll try and set everything up, pour the bleach in there. Again, I've checked for leaks, checked this, and I'm also gonna, this is connection to my PC power supply here. And when I tested out the motor, these wires got relatively hot, so I'm gonna tape them to this aluminum block so that the heat can be dispersed into aluminum. I also have a fan over here which will keep this cool, even though there is a fan in here, but just in case, it should keep it even cooler. And this aluminum block will also just be lying here, so the fan will keep the aluminum block cool. And that should be it. Hopefully the coil's enough to actually cool the bleach, because I did remember like 2 milliliters of bleach released so much heat from 5 liters of 2 milliliters of acetone released a lot of heat from like 5 liters of bleach. So yeah, so I've done the calculations, and so I have 20,000 milliliters of bleach, and since it's at 18% roughly, plus or minus, I think it was 20%. But bleach normally loses its concentration over time, so I rounded it down to 18%. And with that, 3,600 milliliters is pure bleach, and I think I don't have the book with me now, but I think it was around 490 odd milliliters of acetone. So I'm just going to put 500 milliliters of acetone, which is the entire load of my separatory funnel actually. And yeah, now slowly drip that in while everything runs. The coil on this pump is not very strong, so that's why I'm going to actually keep it above this bucket so it can easier for there's less load on the pump, I believe. I don't know, I'm not sure if it needs to be below or above. I think it might need to be below, but then it needs to pump up, and if it's above it can just pump kind of down, which isn't that much. Yeah, so I'm going to put it above. And yeah, that is it. And now I'll just continue doing the experiment. So this drip rate seems to be the slowest I can get, and I think that's actually perfect. So I basically just tighten that thing, and it should lock this thing. And yeah, I actually don't know what that is called. I think it's a stop lock or something. I don't know, but yeah. So yeah. Right, so another update. I've come through a problem where the motor is actually spinning way too fast and this whole thing is shaking, which I do not want. So the only way I could think of slowing the motor is if you had like some sort of variable switch lying around, like a stove switch, which, like, you know, when you change the temperature it actually just changes the resistance. But here's a really fun thing, because in school they teach you about resistance, and this is like a real life application to where you actually could use that information, and this could be anything, right? So here's the circuit. I got 2 wires connected here to my PC power supply, but here I have 2 wires with nichrome wire running across. The nichrome wire has very high resistance. It's used in hair dryers, and that's why the wire heats up really hot, and then the air blows through the wire, heating up the air for the hair dryer. Now here, this is resistance, and this will take away some of the amps this is pushing out. So the reason why we want to lower the amps, because if we lower the amps the motor will spin slower. And the really fun thing was, I took this wire and you move it along and check what speed you want. You can set it to any speed you want just by using this wire or some sort of resistance, variable resistance, maybe switch or some sort. So if I turn it on, it won't spin, right? But you need to give it a quick head start, and it does still kind of shake, but it's mostly this thing here. So I might cut this shorter because it doesn't have to be this long. But you can see it's running at a nice speed. This thing will be filled up with 20 liters of liquid, so it'll be really heavy. So this will be the only thing shaking it, to be honest. The wire, however, does have a downfall where it gets pretty hot. And that is why it's on this glass, a microwave glass, and this will never break due to the heat. And I have a theory that if you could just put this in water, it will just slowly heat up the water, and it will run through the path with the least resistance, and that will be the wire. Even though it's a high resistance, it will have less, the water will have even a higher resistance. If you used distilled water, it will actually run through it will just be better, it won't even be conductive. So, but I worry about the water boiling off. I probably won't get to a boil, because I don't think it has enough heat to get the water to a boil. The outside air should cool down the water before this thing could heat it up, basically. And yeah, so that's the thing. This fan here will be blowing on here to cool it down, because if it does get too hot, I think the resistance increases and it just gets too much. But it will probably stay the temperature it is now for as long as it's on, basically. I think the outside air will keep this temperature to a stable degree. And yeah, so now next step is to line this up, fill it up with liquid, and yeah, and these 2 things I added here was to compress this lid, because it wasn't screwed on. So this lid is compressed on here, so it can shake less, basically. And yeah. Hey guys, so the experiment has started. The motor's turning at a reasonable rate. I had to actually, I think I mentioned this before, but use nichrome wire to lower the amps from the PC power supply so that the motor can spin slower and more controlled. Actually, I did move it from here to here, but I don't think that made too much of a difference, but I'm sure it made a difference. So this actually isn't getting that hot. I don't even need to put a fan on it. It's going to stay at that temperature, which is really nice. I might turn on the fan because of the power supply constantly pushing out amps. This bucket over here was full of ice, like to the top. but it's melted really quickly, like scary quickly. But that's okay, because I got more. It did have to cool down the whole, like, I don't think it's 20 liters, maybe like 19 to 18 or somewhere really close to 20 liters though, to cool down to like with the ice temperature. And I finally got this separatory funnel with a rubber thing here in case anything happens. It won't break the glass spout, I think it's called. And I got it dripping at a reasonable rate. I did want it to go kind of quickly because the ice is going to try and cool this down anyway, so I might as well try put acetone. I sadly do not have a temperature control like a thermometer, but I can just, you know, feel the outside of the can, and it's pretty cold. There's even condensation there, so that's pretty good. This is 500 milliliters of acetone, which is quite a bit, but it should go down. I could probably leave this, but the only thing that makes this like you can't go to bed and wake up type of situation is that the ice will runs out. That's the only thing you have to manage here. And yeah, so hopefully the liquid is in there, is in the bucket swirling. I have the motor turning. I can't actually see if it's swirling or not, but I am gonna hope it is. It has to be movement in there, to be honest, because it did have a blade. So yep. And no leaks at the coils. That looks like a leak there, but I don't think it's going to make too much of a difference. It's not going to fill up the can or anything. I mean, this is mostly water. It's like 80% water. I did work out the mass to 18% though, because I don't know actually how strong it is. But we did throw the stuff into our pool, which was really green. And we threw it quite a bit. I told my dad not to add more, but he did anyway. So that's kind of annoying because I wanted to see how little we can use to get the pool blue. And then I came this morning and the pool was nice and blue, still murky because of all the green algae in suspension, but overall it worked. I mean, you can use bleach for your pool, and my mother's like, oh, bleach is like scary and all that, but in reality bleach and chlorine is the exact same chemical, only difference is calcium and sodium. Chlorine, like powdered chlorine, is calcium hypochlorite and bleach is sodium hypochlorite. You see the same thing. And yeah, and the reason why we want to use the bleach is because we got, I think, like around 100 liters for like 30 bucks, 30 rand. So what is that, like $3? Less than $3, 2.3 maybe. And so yeah, we might as well save money and spend, instead of $10 on chlorine, we can just spend use the bleach that we got. So yeah, so I'll come back. The only thing I'm worried about here is that these wasn't necessary, because once this thing was full, it didn't really wobble at all. It was really stable, because it's understandable, because this thing weighs a ton now. Probably weighs it's over 20 kilos maybe. Bleach is more denser than water though. It's going to be trying to pick this up and decant the top layer. Now, this pump could probably do it, but because bleach won't react with anything in the pump, because I only said no hydrocarbons in the pump, which is understandable. But I don't think I'm going to put a pump in there, because I had to stick it to the side of the wall, because my chloroform is going to be at the bottom. So yeah, so I probably just decant the layer into a big bucket, and there should be around 500 milliliters of chloroform. So it's going to be really a little. Depends how much waste I'm going to get, but that's okay. That's the whole point of this. Alright, so all the acetone has been added. I did do the little bit of acetone a bit quicker because I was getting a bit impatient, and I knew that the extra speed wouldn't make too much of a difference. I have officially ran out of ice, but I do have these things as a plan B, and they're gonna probably cool this water pretty well. It's not as good as ice, but it should help. This thing is actually quite hot right now. It's around, I would say, 30 degrees. Again, I can't test the temperature. Maybe I can test the air temperature through there, but I don't think that's gonna. I could probably stick a thermometer down there, and I might do that, but I don't think the angle is good enough for this to like go straight down. But yeah, so I think this will be pretty good of cooling the water. I'll probably stir this up to get some circulation, because this thing isn't putting out a lot of pressure, as you can see, because it has to get through a bunch of coils. And yeah, and then I'll be done. Then I'll just have to leave this. I'll leave the motor spinning for a long time, about maybe a few hours, just to make sure everything's reacted and mixed. And then what I'll do is I might take a cup of bleach out after it's settled and test if there's maybe more chloroform in there. Like just add a little bit of acetone to the beaker of this stuff and then just maybe adjust from there. Maybe I have to add more acetone than I did. So yeah. Alright, another quick update. I did measure the temperature right now. It's 34 degrees Celsius inside the barrel. I did do a little bit. I took off the resistor basically from the circuit because these two make it spin around that fast, and it's actually pretty nice. It's a good speed and it spins it fast. This water here is going to get warm, but I think it's actually just going to... this thing's 35 degrees. It won't be going up now because there's no more acetone being added. It should just start cooling down by itself. I'm going to keep this motor running. I'm probably going to keep the pump running, but there's not going to be a point when this water reaches the same temperature as that, because nothing's going to happen. So yeah, I think I'll leave the pump running for 2 hours, stirring, come back, and then let it rest for a while, and sorry for the playing. Let it rest for an hour or two to get all the chloroform sunk to the bottom, and then test the top layer with a beaker and more acetone. If so, I'll add more acetone. I have quite a bit left over, and it should be in an excess anyway. This is less than 20 liters, but so the 500 milliliters should be in excess, but you never know what chemicals they get, what concentration. You never know. I'm just gonna do it anyway, test it. It's normally the right thing to do anyway. So yeah. Right, so I've opened it up now. Can't really see what's inside, but I'm gonna do a test. I took the top layer here and check if a little bit of acetone to see if there's anything more left in it. That should be enough, and then give it a quick swirl. Yep, it's gotten murky, so sadly there's more chloroform into it, so I have no idea how much more I can add. To get thing, because yeah, I guess I'll add maybe another 200 milliliters and see if that does the trick, because now that's just proof itself that there's chloroform. I don't know what's actually going on in this layer, but yeah, I'll just pour that back in and probably start the process again. Right, so quick update. It's the next morning, and there's more ice in the freezer now, so I added an extra 250 milliliters of acetone. I added it pretty quickly because I knew it's not going to bring this 20 liters to a boil, and with the cooling coil and everything, and the mixing blade, because if you don't have mixing, it's going to boil the top layer because it's not mixed in. But yeah, I'm letting it mix for about a half an hour, and then I'm going to let it settle for, I think 2 hours should be good enough, or maybe 2.5 or 3 hours, I'm not sure. Which then I'll repeat the test again, put the beaker in on the top layer, and check if there's more acetone, more chloroform, more bleach present at the top layer. So then I'll have to add more acetone to it. I do think 250 milliliters should be enough now, because it didn't actually heat up that much, and I am assuming an extra amount of acetone shouldn't heat it up more. But I'm doing it until it doesn't heat up, or until it doesn't show any bleach in the test, which should come after the other. So yeah, this thing was full of ice, but it really doesn't matter now. I can actually turn the pump off if I want to, because it's not going to continuously heat now, because it's done. There's no more acetone to be added. So I've emptied the bucket, this thing into this bucket as waste, and the rest is in this bucket. That's how much it is there. There is a lot of water in here too, because of the way pouring works. So I'm waiting for this to settle and then separate the water again, then separate it further using the separatory funnel. Let me just open this up and show you. Just move along here with this. See, there's a lot of fine bubbles, which is the chloroform. I'm not too sure right now, what part is what. I know a big portion of this is indeed chloroform, and a big portion of it is water. Now, I'm debating now if I should filter this, but It's actually a lot of water in chloroform. I can't wait to see how much chloroform I actually got. My prediction was around, I think, 500 milliliters, 5 something. So this looks like a lot more. This looks nearly like a liter of chloroform. So yeah, I might filter this probably through some cotton. Yeah, I'm probably gonna filter this. Yeah. But I'm not sure how exactly, because I don't have proper filtered paper. I just have cotton, but then cotton absorbs a lot of. Alright, this is the last of it. In the separatory funnel, I only had to do it twice. This is the one part. This is a 1 liter bottle of chloroform now. So that's not full, obviously. You can see the layer there. There's nothing more in there. This is the chloroform I got. And now this one, you can see the layer is very small on this one, only that much, so I don't need to wait very long for anything to settle up. There is indeed a plastic pipe in there, which I used to put onto the end of the separatory funnel so it can drip into the reaction chamber, and it slipped off, and I think the acetone maybe was not victim, but it probably caused, the acetone caused the plastic maybe to like do something, react with it or something for some reason. But yeah, so I'm gonna decant all of this and then measure how much we got. I think this was around, I think, 300 odd milliliters, so we'll see how much now. I don't have I'll probably have to measure them in 250 milliliter quantities maybe once, because it will fill up the entire measuring cylinder over there, definitely. So, right, just wanted to mention that the plastic pipe did actually cause a problem. That's why all the liquid's back into the funnel. What happened was the plastic pipe started to fall down here, and then I didn't think this was going to happen, but since the liquid is flowing downwards, it created a suction here, so the pipe actually made like a passage for the top layer to go through, which is actually really funny. So I had to just pour it. I stopped it in time, I'm pretty sure, but I did pour the rest back in just to make sure there was no, I don't know, I just didn't, I was pretty sure it looked like there has to be some of the top layer in there, but I couldn't see it with the inside the beaker. So I'm not sure what happened, but I did know that it looked like it was a little bit came through the pipes. I'm not sure now, but anyway, it's just better to restart, which I did now. It's surprising the layers separated even quicker now, so that's good. So yeah, I'll continue with it. So I'm going to put this Epsom salt or magnesium sulphate into here and in the oven at 120 degrees for around 2.5 hours, maybe 3 hours, to drive all the water off it, so I can use it to dry the chloroform. Just to mention how actually clean these crystals are. I mean, look at them on this packet. I almost don't want to destroy them because the heat will probably drive it to clump together. So yeah, but I just wanted to show how clean these crystals are. Beautiful. Alright, so now it's time to distill the chloroform, and this is my setup. Normal 1 liter flask. I got an extra adapter here. I didn't pay for this, I just got it for free with the order for some reason. But it came in really good handy right now to lift this section up, because the separatory funnel will be linked up down here. And since the spout without the extension would hit the table, but now it's enough clearance to put a 50 milliliter flask underneath it, beaker. I found a nice little lid for the thermometer adapter, because what happened was it was an O-ring, but wasn't actually an O-ring. And the thermometer adapter wore out during the nitric acid distillation a while ago, and the thermometer can't fit in this anymore without it, so this cap stops it. It's just used as a stopper now. I use tape here because it's difficult to set it up with these weird lab clamps, normal this, that, water. Now this is going to be a special part. I've put a piece of cotton wool down here to filter out the chloroform, because I'm going to be filling this anhydrous magnesium sulphate that I roasted in the oven in the previous clips in here, so when the drips of chloroform drip in, it actually runs down, absorbs the water, and I can drain off the chloroform through here, and I think that's a decent idea. And yeah, so let me get to that. Alright, so I've gotten all the chloroform in here. Bring that around. So you can see it's quite a bit. Yeah, I've got a thermometer here just to check the temperature. It boils at around 61 to 62 degrees Celsius. So I just want to know when to actually start putting ice into the water, because there's no point melting your ice now when there's nothing actually distilling over. And I've got a bit of a issue that I have a feeling that this, I did shake it up, but I have a feeling that it might block the chloroform, so the chloroform will actually just stay at the top and not run through it. So that might be a kind of a problem. And I probably will have to mid-stop the distillation, take it off, and I hopefully it just doesn't do that, and hopefully it kind of absorbs into it and then soaks out, because that would be really ideal. Alright, so the distillation is nearly finished. As you can see, it's running through the column pretty quickly, which is ideal because it's pretty nice actually. There's no fumes escaping from the side, so it is converting it all into liquid. And it's really not that overloaded. It's still dripping at a reasonable rate. It's not like flowing out there. Sometimes you get it like a solid stream flowing out there, and then you know you're really overloading the column. However, the condense, I don't know where, I think it's converting up here because I can't see any line, or over here. Well, you can see it running down here, so honestly I don't know. Because it doesn't take much to convert it back into a liquid. You can see it running down there. Alright, the distillation is finished. I can't really take it off heating, and I realized it was actually just going to keep on going because of the heat from the sand. You can see there's such a little bit left. That black is just obsidian. I used it boiling stones, and the brown is actually the dirt that came out of it. Very nice and clean chloroform right now. I'm going to try and pass it through this and more. And I've taken the top off here so that it can stop dripping into here, because I don't really want any of this stuff in there to go into my flask, or it might contain a little bit of something I don't want. Ideally I shouldn't have got it down that low, but it happened. It's perfectly clean, as you can see. This is going to suck out any chloroform fumes, so I don't breathe it in. It goes through a scrub, so that's fine, and yeah. Right, so now I've got my chloroform in the bottle here, and that's it. That's the experiment. I don't know the total yield. Actually, I did lose a lot, so I do, like, if you did watch this to the end, I don't recommend using so much magnesium sulphate. Maybe find a different method, because either you have to take maybe a vacuum filtration, which will be pretty good, but that probably will dry. Now, vacuum filtration will probably work because it doesn't really dry the magnesium sulphate at all. It just takes out the liquid, and you can take the wet magnesium sulphate, which will again contain some of your chloroform, and let that dry. I'm letting my dry now and letting all the chloroform away, because I lost, I think, to around 200 milliliters or somewhere like before I had it around here. And now it was around, okay, no, wait, it was around here, and now it was around there, like over here. So, I did lose a lot. So I've added I did this experiment before, smaller scale, I added that in, so now I'm around, like, over here. So yeah, I've covered it in aluminum foil so the sun doesn't react. I've added 3 milliliters exact of ethanol, absolute ethanol, so like anhydrous ethanol, no water in it. I tried my best to get water out of my ethanol, but I have to stabilize it with something. And yeah, I'm normally a good person would measure your yield after the distillation. However, everything contained a little bit of water, everything was wet. I didn't want to wait for everything to dry, because there's no point in throwing your chloroform into a wet cylinder if you just try to do all this effort to remove the water. So yeah, thank you for watching. Please like and subscribe, and comment down below if you have any questions or any advice.